So let's now consider where a nuclear power plant gets the energy that it needs to heat that water, to make the steam, to turn the turbine, to turn the loop in the magnetic field and produce the current. So different types of nuclear power stations use different types of nuclear fuel. One of the very common types of nuclear fuel to use is uranium-235. So uranium-235 can be written as U. The mass number is 235 and the atomic number is 92. Now, in order to get this to undergo a nuclear reaction, it needs to be bombarded with a slow-moving neutron. If it's bombarded with a fast neutron, that neutron will collide with the nucleus and bounce off it, leaving the nucleus unchanged. If it's bombarded with a slow-moving neutron, then that neutron will stick to that nucleus, giving us uranium-236. So we can write the equation for this process as the uranium-235 plus the neutron goes to uranium-236. Now that uranium-236 is very unstable, and so it is going to decay into or undergo nuclear fission, where it splits apart and forms two lighter nuclei which have a higher binding energy per nucleon, and in the process that is going to release energy. So uranium-236 decays into barium-143 and krypton-91, and in this process it releases two neutrons. So this is actually what's known as a chain reaction, as it takes one neutron to start the reaction and two neutrons are released during the reaction. So this means that if we start this reaction and we don't moderate it or stop it, then we end up with an explosion very quickly, which is exactly how nuclear bombs work. So chain reactions can actually be modelled quite nicely with balls and mousetraps. Let's have a look at this model of a chain reaction now. So now we've seen a chain reaction. A nuclear bomb consists of a critical mass of a fissionable substance, and it's generally shaped like a sphere because it's harder for neutrons to escape from a sphere without hitting a uranium nucleus on the way. And so the critical mass actually depends a bit on the shape of the material as well. But if you want to make a bomb, then you need to make a spherical shape. And generally what they did was they had two spheres which were separated. They then dropped them. When the bomb lands, these two spheres come together and suddenly you have a critical mass and it starts to undergo an uncontrolled chain reaction. Now clearly we do not want that to take place in a nuclear power plant. So nuclear power plants have what's called control rods, which are rods that can be dumped down among the fuel cells in order to absorb excess neutrons. So the chain reactions in nuclear power plants are very carefully monitored, and these control rods drop down or up in order to control the reaction rate and to keep it constant. So this diagram here shows the basic design of a nuclear power plant. In the nuclear power plant, we have the fuel, which is generally put as little pellets into a tube, and we have the control rods among those tubes. We then surround all this with water. Now the water is very important for two reasons. For one, it heats up and produces steam, and this steam turns the turbines. But the second function it performs is that the neutrons released from that chain reaction can collide with the water molecules and this is a very effective way of slowing them down. And it's actually only the slow neutrons which are going to cause the uranium to undergo nuclear fission. So we need to slow them down in order to make them useful. So the other main features of our power plant are that we've got the steam going through the turbine, which is connected to the generator, which is connected to the power cables. When the steam has gone through the turbine, it then goes through a condenser, which cools it down. So this condenser is kept cold with another source of water, and then once the steam has been condensed in the condenser, it can be sent back to the nuclear power plant to be used again. So this is a very rudimentary nuclear power plant. There's a lot of design features which are now included to make these even safer. So there's been a few big nuclear disasters in the past. For example, in the USA, there was a big disaster at 3 Mile Island in 1979. In 1986, Chernobyl, which was then in the Soviet Union, had a big disaster at their nuclear power plant. And more recently, the Fukushima Daiichi reactor in Japan had an accident in 2011 following a tsunami. Generally now, nuclear power plants, or the new ones, are very well designed, and it's highly unlikely that an accident is going to happen. However, all nuclear power plants do produce waste fuel. So once the fuel's been spent, then we've still got some radioactive substances left, and these need to be carefully stored in lots of concrete or in lead so that the radiation cannot escape and damage people. So that's a big disadvantage with nuclear power plants. One of the big advantages is that nuclear power plants do not produce carbon dioxide and other greenhouse gases, so they're not contributing to global warming. So there's a lot of debate about how environmentally friendly nuclear power actually is. And if you want to debate it on the forums, then feel free to do so.